Nope. It has to do with the fact that it's squared. So this is kind of like first power.
Oh,
Yeah.
okay. We're doing that now. I
All right,
see
this is
what
like
it is.
geometry, right? You guys all did this in geometry when you did similar shapes. So since we're squaring it, it's kind of like with area. You would actually divide by 5 squared. So whatever your scale factor is, you actually would square it to get the squared to factor down, if that makes sense. So if it was 3, it would be 3 squared. If it was 10, it would be 10 squared. It's going to change based on what your scale is. Interesting. Okay, so we already talked about why you should scale. It does make it easier when you're graphing these things in Desmos if you're able to scale it down or sketch it, right? You don't want to have like 1,000 feet wide. So it depends on how large your designs are also, right? Um, but yes, that is the thing. So if you have an equation with no scaling, like one unit is 1 foot, then you'd have an equation like this with larger numbers, right? And I mean, there's nothing wrong with it. But if it's getting too difficult for you to draw or to include in the Desmos graph, you may want to consider scaling it down. All right, here's an example. Another one. We can talk about it if you want. Let's make one unit on our graph represent 10 feet in the real world. So we're saying one unit is 10 feet. So basically, if you have, this is your A over here, right? This is your original starting. This is A, and this is B. You can see them. They're actually being divided by 10 here, right? A divided by 10 gets you the new number. Same here. B divided by 10 gets you that new number.